This is the solution to problem number 1 from the third midterm. Problem 1 wanted to analyze the relationship between school performance and the second variable, alcohol exposure group. So in part A, it points out that if the two variables, school performance and alcohol exposure, are independent, how many excellent students would we expect to see in the category 3 exposure group? And how many average poor students would we expect to see in the same group? So what I did to find the expected values for the students that fell under the excellent category 3 cell count was I divided the total amount of students that fell under the excellent category, which is 317. I divided it by the total number of students within the study, 2,708 students, and I got the value of 0.1171, which I then went ahead and multiplied that number to the total number of students within the category 3 group, 677. So I got the expected value of 79.25 for students that are in the excellent category 3 group. And to answer the second part of the question for A, how many average poor students would we expect to see in category 3, I did the same thing. I took the number of students that fell under the average poor category, 1,127, divided it by the total number of students within the study, and then I multiplied that value to the total number of students within category 3 to get an expected value of 281.75 students. Then for problem B, we wanted to compare the expected cell counts calculated in part A with the observed cell counts for these categories. Does the discrepancy in the average poor category 3 group provide the same strength of evidence against the independence assumption as the discrepancy in the excellent category 3 group? So I went ahead and what I did was I subtracted the observed values within the categories from the expected. Then I squared that value and then I divided by the expected value. So for students that fell in the excellent category 3 group, I took the value given, 49, which was the observed value. I subtracted it from the expected value of 79.25, which we calculated in part A. Then I squared the difference, divided it by the expected value, and to get the value of 11.55. I did the same for students that fell in the average poor category 3 group. I took the given value of 312, subtracted it from the expected value of 281.75. I squared the difference and divided it by the expected to get a value of 3.25. So if you look at the two values, it's apparent that the discrepancy in the excellent category 3 group is much larger than the average poor category 3 group. Assuming that the null hypothesis is that the two variables, alcohol exposure and school performance, are independent, the excellent category 3 group demonstrates stronger evidence because there is a large difference between what is expected and what was observed. In part C, we were given a table with chi-square contributions for cells with 3 missing components. So in order to find those 3 missing points in the chart, what I did was I took the given observed values and I subtracted it from the expected value. I squared that and then divided it by the expected value. So pretty much what we did in part B. So I did that for the 3 remaining contributions that were missing, and I got the values 11.93 for excellent alcohol exposure group number 1. I got 11.55 for students that fell under the excellent category 3 group, and I got 3.25 for students that fell under the average poor category 3 group. The given information that we observed in part C was that the sum of the provided contributions in the chart equaled 19.75. So I took that value, I added it with the 3 missing contributions that we just calculated to get a total of 46.52. I then went ahead and calculated the degrees of freedom. Because there were 3 missing contributions, I took that number, multiplied it by 2 to get the degrees of freedom of 6. So using the chi-squared chart given to us in part C, I looked up under degrees of freedom for 6, and you can see that the value 46.52 is off the chart. So we just look at the number given for greater than 22.45. So that gave us the information that the right tail area is less than 0.001. Because that value is 0.001 is less than 0.01, which is the given significance level, we reject our null hypothesis. So this suggests that there is a relationship between the variables school performance and alcohol exposure. So this is how you solve problem 1 from the third midterm.